A friend of mine and a member of my thesis committee, Ken Nielsen, he said, nobody understands the origin of life. If they say they do, they're probably trying to fool you.
I mean, yeah, obviously it was a process that took a very long time, and it was very small incremental changes over time. There's, we're not necessarily suggesting that just because it didn't work before the way that it does now, that it didn't have a completely different job prior to that. So,
well, can you have proteins without the machines that decode the RNA, the DNA?
Let's say you can't have the proteins, okay? So what's the step that you can have before that that's no good without the proteins?
Single-cell organisms like Prochorococcus, which is a marine photosynthetic prokaryote, in a single day, it can make all the chemicals it needs to make an exact copy of itself. This single cell is, it's capable of all the complex biochemistry that's essential for life. And cellular structure is essential to the process. Without this cellular structure, as we saw with the apple, when you slice it, the Maillard reaction takes over and makes melanoids. So with this structure, it's possible to make the homogeneous polymers that we need. The cell function grows and reproduces itself. We're now at a point where we can say that, well, the cell is an irreducibly complex structure. You can't make it piecemeal. Only cells can make cells. This was something that Pasteur was proving in his early experiments. Life was coming from life. It wasn't forming spontaneously. So we've got this cell that the only way we can make it is the processes in that cell making a copy of itself.
What I'm saying is maybe that would
the atoms that have to self-arrange themselves into that form.
Yeah, okay.
The DNA is assembled, duplicated, maintained by those very proteins.
Okay,
so how can you have the DNA unless you have those machines?
One of the big ideas that's being pushed is these self-replicating molecules. Another idea is that proteins came first. And the idea is once you have some proteins, maybe they helped make the DNA. Maybe proteins and nucleotides appeared together and they worked and helped each other out. Maybe metabolism came first. Maybe membranes came first. And there are other ideas.
But the machines inside the cell is what make it, though.
Yeah, where did it come from also, if that's possible?
Hydrothermal vents, from deep-sea black smokers to land-bound geysers, mineral surfaces can catalyze the stepwise formation of hydrocarbon chains from carbon monoxide and hydrogen. The reaction results in the growth of hydrocarbon chains of various lengths. Following the violent explosion of the geyser, some water is released into the atmosphere as tiny, microscopic droplets. Under the proper conditions of concentration and pH, fatty acid micelles may join together to form a vesicle. Random fluctuations of the fatty acid bilayer lead to the formation of a cup-like shape. When in close proximity, the ends of the sheet can seal together, forming a spherical vesicle. Individual fatty acids within the vesicle, however, are very dynamic. Fatty acid molecules are constantly entering and leaving the vesicle membrane, and flipping between the inner and outer leaflets. Recent research has shown that single nucleotides of RNA are able to traverse fatty acid vesicle membranes. This animation shows one mechanism by which nucleotides may enter the vesicle. Nucleotides bump into and interact with fatty acid head groups, colored in red, in the outer leaflet. Some of the fatty acids interacting with the nucleotide flip to the inner leaflet, carrying the nucleotide along and releasing it on the inside of the vesicle. As the surface becomes more crowded, nucleotides that are close together can undergo a chemical reaction, resulting in the formation of a polymer, or strand, of RNA. This animation shows a mechanism by which RNA is replicated in a non-enzymatic manner. Single nucleotides find their complementary base on the template strand and undergo a chemical reaction to form a polymer. This reaction is possible because the nucleotides have been chemically activated so as to increase their reactivity.